So this video is going to go through some of the examples on iXL from the Q section. I'm going to look at Q3, 4, 5, and 6. I also have in Schoology, I have the 1-2 transformations, the addition page. This was not part of the original notes, but I did add it in. And this has our two standard form equations, although technically for quadratic this is vertex form, but this is the form you're going to be using for iXL. So we have the absolute value format and the quadratic format, and I'll let you know when we need to reference back here to go over that. So if we pull up section 3, you will see the first one that we have here as soon as it loads. Is find g of x, where g of x is a reflection across the x-axis of f of x equals 2x plus 3. So you want to think about the graph of 2x plus 3. So I think I have my pen tool here that I can use, and I can draw. So 2x plus 3, that's going to be up, at 3, so we're going to be right there. And we're going to be going up 2 and over 1. So we're going to be going there. So we're looking at something like this. And if we want to reflect over the x-axis, I'm going to be switching all these dots to be opposite. So we would be looking at something that is going to actually have the same intercept. It's not going to have the same intercept. It's going to be down, let's see it, 1, 2, at -3. And it's going to have an opposite slope. So instead of going up 2 and over 1, it's going to be going down 2 and over 1, because this point here is 5 above the axis. So I would have to be 1, 2, 5 below the axis. So I'd be looking at something that's going to be going like this. So it's going to have an opposite y-intercept. So it's going to have the y-intercept of -3, which both of these bottom ones do. But it also has to have a slope of -2. So in order to answer that question, we would have to select this bottom left option. And that would be our solution. Now, the next one, we again want a reflection across the x-axis. Let me go through here and just erase my work that I have. So this one, we have, let's come back here. So I'm at 6, -6, so I'm going to be floating up here. I am going to be opening down because this graph is going to be going downward. When you are reflecting across the x-axis, you're going to be opening the opposite direction. So my graph is now going to be opening up instead of down. This point that's here at 6, 6 is actually going to be down at 6, -6. And it's going to be opening up like that. So the x is going to stay the same, so h is the same. The y is now opposite. So instead of this +6, I need to look for something that has a -6. So I'm not using that one. I'm not using this one. The -6 down here, have that on the end, and I also have the -6. But because this graph is also opening up, instead of having the negative in front, that's going to have to be a positive. And that means that this would have to be our solution there, because it's the only one that has a positive out in front. You see we can submit and we're good to go there. So that's really what you want to think about with these problems, is you want to go through, think about what the graph of the original function would be, and think about where it would go, what it would look like normally. If you're having trouble visualizing what's going on, you can use a calculator. So you can actually, if you want to go to desmos.com, this is an internet graphing calculator, which works a little bit quicker than what we have on the Chromebooks. So if you go to Desmos, you can type in what you have in this box here. So if I'm looking at this one, I have 2 times the absolute value of x+7 -7. So we have y equals 2, and then times, I should have a math bar that would come up here. It might be down in this area. Hide those tools. There we go. Okay, so 2 times the absolute value of x plus 7. That needs to go inside there. Plus 7, and then minus 7. And you can see I have my graph here. I can zoom out on that and see what I have. So this automatically graphs it. And then I can click down here, number 2, and I can type in another one. So this question says, g of x is a reflection across the x-axis. So I want to reflect this across the x-axis. So I'm trying to find the appropriate answer where I'm going to be flipped. Instead of opening this way, it's going to be kind of going this way whenever I go through that. And we can type in the next one. So we have g of x, which you can just replace that with a y, equals -2 absolute value of x minus 7 plus 7. So I have y equals -2 times the absolute value, which is here, of x minus 7 and then plus 7. Let's make sure that that matches, minus 7 plus 7. And you can see that one did not reflect over the x-axis because we have our x-axis here. It looks like it kind of turned around, so that one would not be an option. So if we were coming back over here, we could actually go through and eliminate that and cross that out. So let's see if I can bring my tools back up for this. Let's see. No. Okay. That's all right. We can bring that back later. So I know it's not going to be this one, so that's one way to eliminate one of the options. If we go back and look at the next one, we have Q4. This is dilations of functions. This is where you need to pay attention to where your numbers are going to occur. And I'm actually going to intentionally get the first question incorrect because I think that there is something helpful in the explanation for this. You can also learn with an example, the very first question, although if you've already answered some, this won't be an option anymore. But we're going from f of x to f of 7x. Notice that the 7 is inside with the x, so that means that it is going to be acting on the horizontal because it's acting on the x itself. So nothing is going to be happening vertically. So you're not stretching vertically, you're not shrinking vertically because the 7 is on the inside. So you're thinking about stretching horizontally or shrinking it horizontally. Well, anytime you are multiplying the x, you are going to be you're going to be making your graph a lot skinnier, and that is going to happen whenever you shrink. A shrink is the same thing as a compression. Now, I am going to get this incorrect so that you can see there's a helpful chart that is going to pop up here. So if you scroll down, this right here, this is important. So you can see where the A is, that is going to tell you what you're going to have here. So we had AX, because it was inside with the X, and A was some number bigger than 1, so that means it's going to shrink it horizontally. So literally, you should, if you press Control-Shift, and then there's the button above the 6 key on your Chromebook that looks like a box with a couple of lines, you can actually go through and you can drag and snip. This is the equivalent of the snipping tool, and then you can copy that to your clipboard. And you can actually open that up in a separate window and reference that while you're going through and doing these questions. So this one, you see the 1/5 on the outside. So since it's on the outside, that means it's acting in the vertical. And since it's a fraction, it is going to widen out. So vertically, it is going to be shrinking. Stretching vertically is going to make something skinny. Shrinking vertically is going to make it wider. And you can see that's the correct answer there. So again, if you have that chart, you can actually pull up, I think, your documents for that. Let's see here. Maybe your files. I think it's in your files. If you go to your files and then you can look at images, and there's my screenshot. So I could bring that up, double click on that and bring it up, and I can just kind of keep that as one of my tabs, and I can reference that anytime that I need to whenever I'm doing these questions. Okay, so that is Q4. The next one is going to be Q5. That's going to be full transformation. So this is going to be shifting stuff. It's going to be flipping stuff. It's going to be doing dilations and everything else like we've already been doing. So we have this graph. Notice right now, or it tells me I'm doing a translation 10 units to the left and 5 units down. It does not say anything about reflecting, and it does not say anything about changing the dilation. So this 2 out in front is going to stay out in front. This here, this -5, remember that means that H is really a +5. So I'm starting over 5 on the, well, here, since I have my graphs up here, let's go ahead and put this in here. So we have 2 times x minus 5 squared minus 3. Y equals 2 times x minus 5 squared, and then minus 3. So I am taking this graph, and notice that you have the dots here. You can actually hover over top of those and see them. And I am shifting it 10 units to the left and 5 units down. So I'm taking this, and you really want to move the vertex. So I'm moving the vertex 10 units to the left. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's going to move over here. And I am moving it then 5 units down. So I'm over here, and then 1, 2, 3, 4, 5. So I am at the point -5, -8. So my H is going to change to -5, which means I'm going to have x plus 5 in the parentheses. My K is going to change to a -8. So I have a +5 and a -8 in this one, which means that has to be my correct answer. And that's all you have to do for that one. Again, you can use Desmos to help you count. You can also compare. You could type in the equations that they give you and figure out which one matches up perfectly with what you're looking for. The last section in this is Q, and I think I just passed it. Q6, describe the function transformations. This is where you're going to need those notes from the other section, because you're going to have to know what your H is, what your K is, and what your A is. Well, and I guess this one is actually just telling us, asking us how to go from one to another. And again, you can put this into Desmos to look at. So you have this graph of f of x equals -2 times x minus 9 squared minus 8. And we're turning it into the graph of -2 times x minus 9 squared. So basically this -8 on the end is disappearing. That's the only thing that we're doing. The -8 means that I am starting 8 units down, and by it going away, I am now no units down. So to go from 8 units down to no units down, we would have to move up. Because you'd be starting down 8 and you'd be moving up. And we could actually type both of those into here and take a look at that. So I have y equals -2 times x minus 9. Let's see here. X minus 9 squared, and then minus 8. And then when I do my other one, that's y equals -2 times x minus 9 squared. And you can see here, if we look at these, here's this one, here's the new one. All I'm doing is taking the green function, and notice you have colors out here on the side, so it tells you which one is which. You're taking this and you're moving it up 8 units, and so that would be our solution for that one. They may ask you, let me see, jumping and seeing if they're going to ask you. Well, in this one, I guess you're doing a description of what's happening. So this one is doing 2 different things. It's moving left or right and up or down, so you would just have to answer with what both of those are. I hope this was helpful. Again, if you still have any questions on how to do any of these, please feel free to contact me.